Now let's continue our discussion on risk management. So we started this first section on insurance. We discussed how to calculate insurance premium. To be more precisely, how to calculate the fair insurance premium in a perfect capital market. So essentially, you will discount the expected insurance payment, and this discounted number will be your insurance premium. And then we discussed the value of insurance. So, of course, insurance provides value. That's why firms and individuals will want to pay for insurance. So the first one is insurance reduces financial distress cost, and we have discussed this. Insurance can help reduce insurance cost, and we also discussed insurance can reduce tax rate fluctuations. Okay, insurance can increase debt capacity. Well, this is easy to understand, right? Because basically, if your firm is less risky, then it's easier for you to increase your leverage. And insurance precisely has this effect. It makes the firm less risky. Then the firm will be able to increase its debt capacity. And clearly, this could be beneficial because the firm will be able to get higher value from the interest tax shield. And insurance can also provide better managerial incentives. So the argument here is, without insurance, if a firm suffers from a loss, then it's hard for shareholders to understand whether this loss is because of bad luck or it's because the manager is incompetent. With insurance, bad luck is always covered. So if the firm has a bad performance, then it's mostly because the manager is incompetent. So you can see that insurance makes evaluating managers easier. So this will incentivize managers to work harder, right? So that's why insurance can provide better managerial incentives. So this line of argument is related to corporate governance, how the firm is governed. Insurance can help risk assessment. So the argument here is when a firm buys insurance, then it can get help from insurance firms, because insurance firms, they are specializing in assessing risk. So by buying insurance, firm itself will have a better understanding of risks it faces, right? So that's why insurance can provide value by helping the firm assessing its risk. Now, insurance has values. Obviously, insurance will have costs. The obvious cost is you have to pay this insurance premium. And due to market imperfections, in reality, the cost of insurance will be higher than the fair premium. So if you use the formula, right, in this chapter and you calculate the fair premium is $10, then maybe in the real world you have to pay $12. So why do we see that the cost of insurance is above the fair premium? Well, there are several reasons. The first reason is because of transaction cost. If you want to buy insurance, you need to buy from a insurance firm, and the insurance firm has to cover its cost, right? It has to cover its marketing, its office, its salaried employees. So obviously, the insurance firm has to charge extra fees to cover these transaction costs. And the second one is related to asymmetric information. So this will generate informational costs. There are two kinds of information costs. The first one is called adverse selection. If you have learned intermediate microeconomics, then you could have heard about this. But in our lecture, right, in this class, adverse selection basically means a firm with higher risk is more likely to buy insurance. And from the insurance firm's perspective, this is costly, right? Because it basically means that if you're selling insurance, then you're selling your insurance to higher risk firms. And the second reason is due to moral hazard. In this class, moral hazard means if a firm buys insurance, then this firm will take more risk. So this means accidents will be more likely to happen if the firm buys insurance. Again, from insurance firm's perspective, this is costly, right? Because if buying insurance distorts the firm's perspective or incentive, this means the firm takes more risk, then the insurance firm will suffer because it's more likely for this insurance firm to pay this insurance payment. And to compensate these above costs, sure, insurance firms, they have to charge higher premium. Okay, now let's see this example here. It says your firm faces a possible $100 million loss, and you will insure against this loss. And because of the tax benefits and the avoidance of financial distress and insurance costs, each $1 received in the event of a loss is worth $1.5 to the firm. There are two policies. One pays $45 million and the other pays $100 million if a loss happens. The insurance firm charges 20% more than the fair premium to cover the additional costs. To account for adverse selection, the insurance firm estimates a 5% probability of a loss for the $55 million policy and a 6% probability of loss for the $100 million policy. Suppose the beta of the risk is 0, so you could use this 5% risk-free rate as a discount factor. Which policy should the firm choose if its risk of loss is only 5%? Which should it choose if its risk of loss is 6%? So first, if you read the problem, it says to account for adverse selection, the insurance firm estimates a 5% probability of loss for this $55 million policy, and 6% probability of loss for this $100 million policy. So why this is called adverse selection? Well, it's because if you look at the number, it basically means that a firm with a higher probability of loss will buy more insurance. Right? So this is exactly adverse selection. Okay, now let's go back to solving this problem. Which policy should the firm choose if its risk of loss is 5%? Right? So let's say we have a firm, its loss has a 5% probabilities, and it has two policies, right? Two policies. So let's start from policy 1. Now, to understand which policy the firm prefers, we need to calculate the net present value from these two policies. And the firm will choose the policy with a higher net present value, right? So it's again a problem of calculating NPV. So policy 1 will pay out 50 oops, sorry. So policy 1 will pay out $55 million, and the probability is 5%. So we should use 5% times 55. So this is the expected insurance payment. And the discount rate, we should use 5%. This is just the fair premium, right? And the problem tells us the insurance firm will charge 20% more than the fair premium. So the cost of this insurance should be this number times 1.2. This gives us a number which is $3.14 million, right? So this is the cost. So let's call this as policy 1 cost. And then again, we could also calculate policy 2's cost. Policy 2 cost. And the insurance firm estimated that a 6% probability, right? So we should use 6% times the 100 million insurance payment, discounted at 5%. Again, this firm charges 20% more than the fair premium. So this will give us a cost of $6.86 million. Okay, now our task is to understand the NPV of these two policies for the first firm with 5% loss rate. So let's call this as 5% firm. So for this firm, the NPV of policy 1 equals, first it has to pay for this 3.14 insurance premium. And then if the accident happens, it will get $55 million. And it happens with 5% probability divided by 1 plus the discount rate. And this will give us a number of 0.79. And then the NPV from the second policy would be 6.86 plus, again, the second policy will pay out $100 million. And we know that this will only happen with a probability of 5%. So again, discounted at 1 plus 5%. So this will give us a number of 0.29. So this basically means for this low risk firm, right? For this firm with 5% loss rate, it will prefer this insurance. That is the insurance with lower insurance payment, $55 million. Now let's look at the other firm. The other firm is this 6% loss rate, higher risk firm, right? This high risk firm. Now, if this firm buys, okay, let me use a different color. If this firm buys the first insurance, it will pay the same insurance premium. And for 6% accident would happen, and it gets $5 million, discounted at, again, 5% discount rate. And this gives us $1.57 million. And then if it buys the second insurance, now the same insurance premium, and with 6%, it get $100 million. And this will give us a number of 1.71. We can see that now the high-risk insurance firm will take the insurance with a higher insurance payment, a more expensive insurance. And you can see that we're getting this kind of result because of this number, because of the probability of loss for these two firms, right? Okay. Okay, let's review options and futures. I am doing this because if you want to understand how to hedge commodity risk, interest rate risk, currency risk, then you have to understand options and futures. And I know you should have learned options in corporate finance too, but most likely you have not learned about futures. So it's beneficial if we go through these basic definitions and concepts of options and futures. Okay. So first, when we're talking about options, we have two kinds of options: call option or put option. A call option gives its holder the right to buy an asset at the exercise or strike price on or before the expiration date. So you basically have several important elements here. The first is, if you're the buyer of the call option, then you have the right. Here the word right basically means you can choose to exercise the option, or you can let the option just expire. And then you will be able to buy the asset at the exercise price. And it's also called strike price. And you can do this on or before the expiration date. Okay, let's look at this example here. So let's say there is a call option. And this call option is written on 100 shares of Apple stock. And this option has a strike price of 150. And the expiration date is April 16. Then this basically means that if you're the buyer or the holder of this call option, then on or before April 16, you can buy 100 shares of Apple stock at $150 per share. And similarly, we can define put option. A put option gives its holder the right to sell an asset at a specified exercise or strike price on or before the expiration date. For example, a put option on 100 shares of Apple stock with a strike price of 150, and this option expires on April 16. This means if you have this put option, then on or before April 16, you have the right to sell 100 shares of Apple stock at the price of $150 per share. If you want to buy either call option or put option, then you have to pay the price of this option. And the price of the option is called the premium. So basically, buyers of options will pay the premium to option sellers. And sellers of options are also called writers of options. And if you buy option, you're taking a long position in this option contract. When you sell option, you're taking a short position in the option contract. So if you're the holder of this option, you have the right. But if you're the writer of this option, then you will have the obligation. That is, if the holder of the option exercises its call option, then you will have the obligation as a writer to make delivery of the underlying asset. Similarly, if the holder of a put option exercises its contract, then as the option writer, you have the obligation to take the delivery of the underlying asset. Now let's recall how to calculate the payoff of options and the profit of options. So let's say a option has the exercise price, which is denoted by X. And let's say on the expiration date, ST is the stock price. Now, if the market price of the stock is larger than the exercise price, then the call option holder will want to exercise this call. So the payoff to the call holder is the difference, ST minus X. But if the market price of the stock falls below the strike price, then the call option holder will not want to exercise this call. So in this case, payoff to this call option holder is just 0. And for a put option holder, if the market price is larger than the exercise price, then the put option holder will not want to exercise the put option, because put option gives you the right to sell at the exercise price. If the market price is larger than the exercise price, then it's better for you to sell in the market. So in this case, the payoff to put option holder is just 0. But if the price falls below the exercise price, then in this case, the put option holder will want to exercise the put option. So the payoff here is the exercise price minus the market price ST. So this is just the payoff to option holders. As the option holder, you also need to pay premium to buy your options. So the profit to an option holder is just payoff minus option premium. And option contract is a zero-sum game. This means the seller's payoff is just the negative of the buyer's payoff. That is, if the payoff to the option buyer is $10, then the payoff to the option seller is just minus $10. And it's the same for profit. If the buyer earns a profit of $10, then the seller would suffer a loss of $10. Okay, now let's see an example. So let's say we have a call option, and this call option has a exercise price of 100. So you can see that the payoff equals 0 if the stock price is smaller than 100, and it equals stock price minus 100 if stock price goes above 100. So if you draw a picture, then you can see that, let's say I put the stock price on the horizontal axis, and the vertical axis is just money, right? It's either your profit or your payoff. Then you can see that if stock falls below 100, your payoff is just 0, given by this. And if stock price rises above $100, you can see that if you draw this equation, you can see that it should be a 45-degree straight line, and this line will have a intercept on x-axis at $100, right? So it should be a line looking like this, right? So this is your payoff. And then let's say you have paid a premium on this call option. Let's say the premium is $14. Now, how do you calculate your profit? Well, we said profit equals payoff minus your premium. So basically it means to find out your to find out your profit, you can see that if stock drops below $100, your profit is just minus 14, right? Because it's just 0 minus 14. And if stock price rises above 100, then your profit is stock price minus 100 minus 14. So your line would just look like this. Right? Essentially, you can see that it's very easy for you to go from payoff to profit. What you need to do is you just shift this green line downward for $14. Right? So this will give you the profit line. And now let's calculate the seller's payoff and profit. Okay. Well, we learned the seller's profit is the opposite of the buyer's profit, right? And the seller's payoff is the opposite of the buyer's payoff. So what you can see here is if buyer's payoff looks like this, then to find out seller's payoff, you can just flip this picture. That is, the seller's payoff should be like this. And we also learned buyer's profit is given by this dashed yellow line. Then flip this curve. You will have the seller's profit, right? And you can see that it's actually pretty easy to understand this curve. So if you look at this curve, so here you can see that if stock price drops below $100, then the call option holder will not exercise the call. So the call option will just expire. And in this case, the payoff to this option seller is just a 0. But additionally, the call option seller have earned the $14 premium. So the profit to this option seller is $14. And then you can see that if the stock price rises above $100, the option buyer will exercise the call, and option buyer will earn positive payoff. This implies the option seller will suffer from a loss. So that's why you get losses whenever the stock price rises above $100. However, if you think about this option seller's profit, then its loss will be partially offset by the premium, the $14 premium. So that's why you have to shift the payoff curve upward to get the profit curve for the option seller. Similarly, we could also talk about the payoff and profit to put option. So here you can see that we're looking at a put option, right? This put option has the exercise price of $100. We learned the payoff of a put is 0 if stock price is larger than the exercise price, and the exercise price minus stock price if stock price is smaller than the exercise price. So this basically means if the stock price is below $100, then we will have 100 minus stock price. So this should be a 45-degree line, and it will have a horizontal intercept at $100. So this means the curve should look like this. And if stock price rises above $100, of course you know now the payoff is just 0. So the red curve gives us the payoff curve for a option buyer. Again, to get the profit curve, we have to shift the payoff curve downward. The reason is because the put option buyer has paid option premium to purchase the put options. So it's a cost. So this will drag down the total amount of money the put option buyers can finally get. That's why you have to shift downward this payoff curve to get the profit curve. Okay, now let's talk about futures contract. So futures contract implies the obligation to make or take delivery of the underlying asset at a predetermined price on a predetermined date. There are several important things to notice here. First, if you enter into a futures contract, then you will have the obligation, right? So you have the commitment. You have to fulfill your obligation. And then You will buy or sell the underlying asset at a predetermined price. So this price is called futures price on a predetermined date. So this date is called delivery date. And you can either make delivery or take delivery. Well, basically, if you enter the long side of the futures contract, then you will take delivery. It means you will make the purchase. You're a buyer. If you're entering the short side of the contract, then it means you will make the delivery. That is, you're the seller. So let's see a fictional futures contract here. So let's say there's a futures contract. This contract is written on 1,000 ounces of gold with a futures price of $2,000 per ounce. And the delivery date is March 24. So what you can see here is you have the delivery date, March 24, and you have the future price of $2,000 per ounce. And of course, you have the underlying commodity, that is gold. To be more specific, you have 1,000 ounces of gold. So if you're taking a long position in this futures contract, it means you make the commitment to purchase 1,000 ounces of gold on March 24 at a price of $2,000. If you enter the short position of this futures contract, then it means you have the obligation to sell gold on March 24 for $2,000 per ounce, right? So you can see that a futures contract has two sides. On one side, you have the long position. On the other side, you have the short position. And the guy on the long side or in the long position will be the buyer. And the guy on the short position will be the seller. Oh, this is just a picture of actual gold futures. So you can see that you have these different delivery date. And then these are just futures price. Of course, you have all these details here. They're not important. I'm showing this picture to you, just trying to give you some idea how actual gold futures look like. Okay. Oh, oops, sorry. Oh, boy. Oops. Let me reopen the lecture note. Okay. So, how do you calculate your profits from futures contract? So, if you're taking a long position in the futures contract, then on the delivery date, your profit is the spot price at maturity minus the original futures price. So here, let me explain. First, at maturity. Well, it basically means on the delivery date. Now, what is the spot price? Spot price is essentially market price. So, spot price at maturity means the market price on the delivery date, right? For example, let's say you're on the long side of this futures contract. The future price is 2,000. And on March 24, let's say the spot price is 2,100. Now you can see that your profit per ounce would be 100, right? And your total profit would be 1,000 ounces times 100, which is $100,000. And then, just like options, futures contract is a zero-sum game. So the profit to the short position would be the negative number of the profit to the long position. So basically, profit to the short position equals the future price minus the spot price at maturity. So again, you can see that if you have entered the short side of this futures contract, then if the spot price is 2,100 on the delivery date, then you will suffer a loss. You will suffer a $100 loss per ounce. So your total loss would be 1,000 times minus 100. So you will lose $100,000. Okay. Also know that when you sign futures contract, you don't need to pay anything, right? This is different from options. If you're the option buyer, you have to pay an option premium. And if you're an option seller, you will get that option premium. But for option contract, if you just enter this contract without paying or receiving any premium. Okay, now let's look at these. So the important thing is about these two pictures, these two. So here we want to understand how futures profits are related to the spot price. So let's say the spot price at maturity or on the delivery date is given by PT. So let's say the original futures price is given by F0. So we learned if you're taking a long position in the futures, your profit equals spot price minus future price, which means if you're long futures, then your profit is PT. Right? If you're long, your profit is PT minus F0. And if you're short, your profit is F0 minus PT. So this means if we wanted to draw a picture, right, for these two results, it means that, let's say, let's look at this guy here. So here we are putting the spot price at maturity on the horizontal axis, and the vertical axis is the profit. So what you can see here is, according to this formula, if we put PT on the horizontal axis, then we should get a 45-degree line, and it's upward sloping, and it should have a intercept at F0, right? So this is the curve for the long futures profit. And then for the short futures profit, we will have, again, a 45-degree line, but it is downward sloping. and it will have the same intercept at f0. And for comparison, we also have have curves for call option, and we have learned about this in the in previous section, and we know that if you have a call option, then this would be the payoff, right? And this would be the profit. Obviously, you can see that if you take a long position in the futures, your payoff will be different compared with taking a long position in a call option, right? So these are two different derivatives. Okay, so that's for today, and in the next class we will continue to learn about futures.